Okay, I have the first practice test, so practice test 1 pulled up on my computer right now. I'm going to go through the calculator portion with you just to kind of review the calculator, and then I'll make a video for that, and then I'll make another video with just a couple of the practice problems from the test so that you can see how I work those and just to kind of go over a couple things. I'll also show you the formulas that are on the test. I have that on a different document that I've already posted, but I'll kind of go through it with y'all. We're going to give you the formulas for the test, so and just kind of what each one of them means. So I'll do probably 3 different videos for this little review. So the first problem, we have a recursive sequence right here. A of 1, A of 2, A of 3, and then our A of n depends on the previous 3 terms. First thing I'm going to do, because this is really not hard, before I put it in the calculator, is I'm going to find A of 4 and A of 5, just so I can check and make sure mine is right. I actually started a video a minute ago, and I had typed it in wrong in the calculator, and it didn't match. So it's good to check just to make sure you don't make a mistake when you type it in. I had just put a times instead of a plus, so it didn't work, but then I would have had the wrong answer with no work shown. So I'm going to say that A of 4 is, this is A of 4 minus 1, so that's A of 3 plus A of 2 plus A of 1, which those are just cancel, so A of 4 equals 2. And then I'll do A of 5 also. I mean, this doesn't take any time, it's just a quick little check, just to check yourself. So 2 plus the previous one, which is 2 minus 1, so you get 3. So I have my next 2 terms in the sequence just for a quick check, just to make sure I didn't mess up, because clearly it's possible. So I'm going to go up here to my calculator. Mr. Blackburn showed it on the graph. I showed it on the graph and also in a calculate page. There are advantages to both. So I'm going to do both on here. Do whichever one you're comfortable with. It'll work both ways on the calculator. I've tried it both ways for the test, so it works. So you have a graph. You're going to change your entry to sequence. And then you might have the test pulled up so you can see what I'm typing in. So when you do this, you might actually look at the test. But I'm just going to type in this A of n formula that I have right here. So this formula that I have right here, I'm going to type that in using the U1 instead of the A of n, because that's what the calculator has for me. So I have U1 of n minus 1 plus U1 of n minus 2 plus U1 of n minus 3. So that's the formula. My initial terms, I have 3 of them. 1, negative 1, and 2. Okay, so that's the formula. Hopefully I have it right this time. And there are, let me move this out of the way. There are my terms. So those are the first few dots. Go to menu, trace, and we want to graph trace. So you can see down here in the bottom, I don't know if my pointer shows, but down here in the bottom you have when n equals 1, your answer is 1. Our next one, when n equals 2, it's negative 1. Our third one, when n equals 3, it's 2. So those are the 3 that you put in. Now these next 2 should match what we did. So when n is 4, your answer is 2. That's what we got. And when n is 5, your answer is 3. So I'm pretty confident that I have the right equation in there. Now if I just type in, we're looking for A of 20. That's what it's asking for on the test. Right here, A of 20. So I'm just going to type in 20, and hopefully it works. Okay, so I got this down here, 3.33 e to the 4. I don't know exactly what that is, right? So I'm going to change my float. So I'm going to come over here to the menu and go to settings. And you can see that I'm only displaying 3 digits. I'm floating 3. I'm going to change that to like 6. Hit OK. You can make it default if you want. I'm just going to hit OK. And now I see 33258. So 1, 2, 3, 4, 5. That's 5 digits. I told it to show 6, so that's probably the answer. So my answer here would be 33258. All right, that's one way to do it. The other way to do it, come on, graph calculator. There we go. The other way is if you open a calculate page. So we open a calculate page. We're going to define our variable. So we go to menu, actions, define. It's the first one. And I'm going to call it f of a equals. Down here, I hope you can see this. Come on, little cursor. Down here, this little button above the times sign, it has our piecewise function. So I'm going to pick this one. I actually am going to have 4 pieces on this one because I have 3 initial terms. So I'm going to change that to 4. So you're going to put in your initial terms. So your first one is 1 when a equals 1. I'm just pushing tab to get between these. The next one is -1 when a equals 2. The next one is 2 when a equals 3. And then the last one, we're going to do the f of a minus 1 plus f of a minus 2 plus f of a minus 3. And that is when a is greater than 3. All right, done. So we're gonna try a couple. F of 4, since we did that one already, is 2. That's what we got. F of 5. Hopefully we get 3. Okay, those worked. Now, on your calculator, this one is going to take a little bit of time because this one is a big number. I've tried the one on the test, and it works without taking 10 minutes. So if you don't want to get your calculator stuck in the, like, trying to figure it out, with the hourglass mode or with the little timer mode, then don't type this one in. But it is f of 20, and so it gets 33258. So I got that one also. Now yours, because this is a faster processor, I guess this one works faster. So don't do this on yours if you don't want it to get stuck there. But the one on the test will work. So try the other practice test. If you need practice on it, try ones we did in class or make up your own. Just don't make it too big of a number. Maybe do f of 10 or f of 5. I guess we did 5. F of 10, not such a big one, but that works. Okay, the next one on your test is just a simple evaluate problem. I just want to remind you where the things are on your calculator. So again, you probably want to be looking at yours, but we have, first of all, we need to make a divided by, so control divided by. On the top, you have 5, and then the summation, I don't know if you can see my cursor, is up here, just where we found that piecewise function. Put the summation on there. And then just type in what you see. So I have, and it doesn't matter what variable you use, I just use the ones that they're given. If you hit tab, it'll go between between the different pieces easily. 20, and then we're going 10 minus 2n. Make sure anything that's being summed is in those parentheses. So if you have like times something, or if you have 2 different things in the summation, make sure you have one big parentheses for the summation. And then to the -16. 275 over 4, that's a good answer. Other things you might need in your calculator, if you go down here above, next to the G, if you need the factorial sign, if you have any factorials, you can find it there. You can also find it if you hit, if you hit Control and then this catalog button, your factorial sign is in there. So 2 different places you can find it if you need it. All right, and then the last problem, so we got 275 over 4. And then the last problem on this calculator section, not really hard calculations on the calculator, it's just kind of a confusing problem. So this is on both of the practice tests, or a similar problem. But a rubber ball bounces to a height that is 80% of the original drop height each time it bounces. If a ball is dropped from a height of 10 meters, find the total theoretical distance the ball will travel as it bounces an infinite number of times. Okay, so we have this ball, right? It's dropped. It goes down 10 meters. Then it bounces. It's going to go up 0.8 times 10, right? But then it's going to fall that same distance, 0.8 times 10. Then it's going to go up 0.8 times 0.8 times 10, right? 80% of that one. And then it's going to fall. 0.8 times 0.8 times 10. So this is a recursive geometric, not recursive, this is a geometric sequence, right? It's going to keep going 80% of the previous one, so times 0.8. So if we write out our terms, we have 10 plus 10 times 0.8 plus 10 times 0.8. So that's these two, right? So we've done this one, and we've done those two. Now it's going to go again. 10 times 0.8 times 0.8, which is 0.8 squared, plus 10 times 0.8 squared again. And it's going to keep going, cubed to the fourth to the fifth, all that. So I really have 10 plus 20 times 0.8 plus 20 times 0.8 squared plus 20 times 0.8 cubed, so on and so forth. If I wanted to put this in a summation, these are the things that are the same every time, right? So I have 10 plus the sum, k equals 1 to infinity, because this is an infinite sum, of 20 times 0.8 to the k. So now I have it in summation form, just like our infinite sums that we do. The formula for an infinite sum is a over 1 minus r. So we're only looking at this part when we're doing that summation, right? So we need to figure out what a to the 1 is and 1 minus r. This 10 we're just going to add at the end. So it's actually going to be 10 plus 20 times 0.8, which if you need to go over here and do it in your calculator, you can. 20 times 0.8, that's your a to the 1, is 16. So you have 16 over, and then our r is this rate that we're being multiplied, 1 minus 0.8. And then you put all that in your calculator. 10 plus 16, oops. Come on. There we go. 16 over 1 minus 0.8, and you get 90. So that's our infinite sum. So this is 90 meters. That's, if it kept going and going and going, right, it's going to get little smaller and smaller little bounces, and that's how far it went. Okay, there's the end of this video.